I've always been fascinated by the way our bodies work, and today, I want to dive into something we often take for granted, our sense of hearing. It's not just about our ears, you know? It's this whole intricate system that lets us experience the world through sound. And let me tell you, it's way more complex and amazing than most of us realize. Okay, so let's start with the basics. Our ears are like these incredible biological machines divided into three main parts: the outer ear, the middle ear, and the inner ear. The outer ear is like a funnel, catching sound waves and directing them inward. Then there's the middle ear, which is honestly kind of wild. It's got these tiny bones. And I mean tiny, they're actually the smallest bones in your entire body. Now these little bones, they're called ossicles, and they're like nature's own amplifiers. And the inner ear, oh boy, that's where things get really interesting. It's got this snail-shaped structure called the cochlea that's filled with fluid and lined with thousands of tiny hair cells. These hair cells are the real MVPs of hearing. So, how do we actually hear? It's this amazing process that starts with sound waves entering our ear canal. These waves hit the eardrum, causing it to vibrate. Those vibrations then travel through those tiny bones we talked about earlier, getting amplified along the way. When they reach the cochlea, that's where the magic happens. The fluid inside starts to move, causing those hair cells to bend. Now here's the cool part. When these hair cells bend, they create electrical signals. These signals travel along the auditory nerve straight to your brain. And get this, your brain doesn't actually hear anything. It just interprets these electrical signals as sound. Isn't that wild? Your brain is basically translating electricity into the music you love or the voice of someone you care about. All right, let's talk about pitch. You know, whether a sound is high or low. There are actually two main theories about how we perceive pitch, and they're both pretty cool. First, there's the place theory. This theory says that different parts of that cochlea we talked about earlier are sensitive to different frequencies. So, high-pitched sounds activate hair cells near the base of the cochlea, while low-pitched sounds activate cells near the tip. Then there's the frequency theory, which is all about timing. This theory suggests that the rate of nerve impulses traveling up the auditory nerve matches the frequency of a tone. It works best for low-pitched sounds, but, you want to know something interesting? Current thinking is that these theories work together to give us our full range of pitch perception. It's like your ear is using multiple strategies to make sure you don't miss a beat or a pitch. Now you might be wondering, how do we know where a sound is coming from? Well, it's all about teamwork between your two ears and your brain. Your brain is constantly comparing the input from both ears to figure out the direction of a sound. There are two main cues it uses, the interaural time difference and the interaural level difference. The ITD is all about timing. If a sound reaches one ear before the other, your brain knows it's coming from that direction. The ILD is about volume. The ear closer to the sound source will hear it louder than the other ear. Your brain puts these cues together to create a 3D sound map. It's like your brain is playing a constant game of Marco Polo with the world around you, using sound to navigate your environment. Okay, so here's something that might blow your mind. Your ears aren't just for hearing. They also play a crucial role in your sense of balance and spatial awareness. This is all thanks to a part of your inner ear called the vestibular system. It's like this tiny gyroscope in your head that helps you stay upright and know which way is up. The vestibular system has two main parts, the semicircular canals and the vestibule. The semicircular canals detect when you rotate your head, while the vestibule senses gravity and linear movement. It's constantly sending signals to your brain and muscles to help you stay balanced. You know that dizzy feeling you get after spinning around? That's your vestibular system trying to catch up with the world around you. Unfortunately, our amazing hearing system can sometimes run into problems. There are several common hearing disorders that can affect how we perceive sound. Conductive hearing loss happens when there's a problem in the outer or middle ear that blocks sound from getting through. It's like trying to listen to music through a thick wall. Then there's sensorineural hearing loss, which is caused by damage to those important hair cells in the cochlea or to the auditory nerve. This can make sounds seem muffled or distorted. Another common issue is presbycusis, which is age-related hearing loss. As we get older, we tend to lose the ability to hear high-pitched sounds first. And then there's tinnitus, which, well, I actually have some personal experience with that one, so let's talk about it in more detail. So, tinnitus. It's this persistent ringing or buzzing in your ears that just doesn't go away. I've been dealing with it for a while now, and let me tell you, it can be pretty frustrating. For me, it's most noticeable when everything else is quiet, like when I'm trying to sleep. It's like there's this constant background noise that only I can hear. But you know what? While there's no cure for tinnitus, there are ways to manage it. I found that using white noise machines or soft music at night helps mask the ringing. Mindfulness and relaxation techniques have also been really helpful in reducing stress, which can make tinnitus worse. And of course, protecting your hearing by avoiding loud noises is super important to prevent it from getting worse. While living with tinnitus can be challenging, these strategies can really make a difference in managing it day to day. Now let's talk about something really cool: auditory illusions. Just like optical illusions can trick your eyes, there are illusions that can trick your ears. One of the most famous is called the McGurk effect. It shows how what we see can actually change what we hear. These illusions show us that hearing isn't just about our ears. Our brain plays a huge role in how we perceive sound. It's constantly trying to make sense of the information it's getting, sometimes filling in gaps or making assumptions. It's like your brain is this over-eager intern, always trying to be helpful, but sometimes getting things a bit mixed up. So, after all we've learned about how amazing and complex our hearing system is, it's pretty clear that we need to take care of it. One of the best things you can do is protect your ears from loud noises. That means using earplugs or noise-canceling headphones in noisy environments, and keeping the volume down when you're listening to music. Remember, once those hair cells in your cochlea are damaged, they don't grow back. And there you have it, a journey through the incredible world of hearing. From the tiny bones in your middle ear to the complex way your brain interprets sound, it's all pretty amazing stuff. Next time you listen to your favorite song or hear a loved one's voice, take a moment to appreciate the intricate process that makes it all possible. And hey, take care of your ears. They're the only pair you've got.